All right, this is part one of linear inequalities. And first one is just make sure we remember our inequality symbols. This one, the way that you read it from left to right, the open part is on the left-hand side, so it's greater than. My computer is moving so slowly. I am sorry. And then this one would be less than. Again, read it left to right. The small part is at the beginning, that's why it's less than. This, when you have the greater than sign with the line underneath it, that means it's greater than, or it can be equal to. And then this is less than or equal to. So those are the four inequality symbols. Now, a linear inequality, the equal sign in a linear equation has been replaced with an inequality symbol. So instead of seeing y equals mx plus b, you might see y is less than mx plus b. It can be any of those four. I just chose the less than symbol. So now, with the linear inequality, the graph is a shaded region of the coordinate grid that's bounded by a line. All right, no more is the graph just a line and it's all the points on the line. Now it's an entire shaded region. So as soon as this picture pops up, I can show you that. There we go. So on the left, that's a linear equation. All the points that lie on the line is a solution. Now for this one, because the inequality is less than or equal to, any of the points that lie on the line or in the purple shaded region, those are the answers. Those are the solutions. So there's lots of solutions. Now you're going to hear boundary line a lot. For greater than and less than, you would use a dashed line. You use a dashed line because it's not equal to. So in this example, those two red coordinate points that you see are not solutions. All right, they just show that that's the y-intercept, and they use the slope rise to run 1 to find the line. All right, the solutions are all the blue shaded because it's a dotted line. None of the points that are on that dotted line will work. None of them are solutions. However, for greater than equal to and less than equal to, because it can be equal, use a solid line. So those two lines that you see, or those two dots, excuse me, that you see on the blue line, those are solutions. And then that whole shaded region, that whole blue shaded region, any point in that region is a solution to that inequality. So now the solution of an inequality is an ordered pair that makes the inequality true. And like I just said, there's going to be many of them, not just one. So now we are going to have to do some shading for our answers. So determine which region to shade. My suggestion is to use the coordinate point 0, 0 as a test point. All right, it's very easy to multiply by 0 and add and subtract by 0. So 0, 0 works wonderfully. Now if 0, 0 can't be used, if that happens to be on the line, then try 1, 1. If that doesn't work, 2, 2. All right, and you can see where I'm going with this. But 0, 0 is the easiest one to use as a test point. We'll be talking about this a lot. Now, if the test point makes the inequality true, if it works, all right, then that means the test point is a solution. Yes, it works, then yes, it's a solution. You would shade everything in that region. If the test point makes the inequality false, if you do the math and you go, oh no, that's not right, then guess what? That test point is not a solution, and anything in that region wouldn't work, so you would shade the opposite region, the region across the line. So remember, each point in the shaded region is a solution to the linear equality. I'm going to ask you a question about this one, about which point would be a solution to this, okay? So make sure you're looking at it. And we're going to do a lot of this tomorrow in class. All right, I will see you then.